Hello, everyone, and welcome to episode 40 of Diabetics for Diabetics Radio. I am your host, Bowie Madison, and today's episode is titled GAD, GABA, and Diabetes. Why GAD autoantibodies are used as a predictor of type 1 and what that means for GABA as a potential treatment for those with type 1. Now, if we haven't met yet, my name's Bowie. I've been creating community around the idea that we don't have to have type 1 diabetes anymore. I was diagnosed in August of 2001. That means I've had it for over 22 years. I am researching into all kinds of marginal research topics, kind of taking whatever puzzle pieces the research alternative medicine will give me and trying to put together a comprehensive plan to heal. And I've gone to TikTok mainly. I've also got the podcast here in my YouTube channel where I'm sharing. The idea is to have as many people with their hands on this as possible. That way we have more people with type 1 trying different things, testing things out, and seeing what works so that we can come back, share, and put this all together, essentially. All right. So if you're not already following me on TikTok, there's my handle there at Bowie_Madison. Obviously, subscribe here on the channel. And let's talk a little bit more about GAD and GABA. Now, the GAD autoantibody is relatively new on the type 1 scene. I know for me, having been diagnosed in 2001, there was no such thing as an autoantibody panel. That technology, that information was not around. I think it probably started in the maybe 2010, 2011, 2012 area when people who were getting diagnosed were being regularly tested for those autoantibodies. So this information may be brand new to you, having had diabetes a little bit longer. But again, even if you did have the panel done and you were told that it meant that you were on your way to becoming diabetic, or maybe it was used as a diagnostic tool and telling you you had type 1, that doesn't mean we really understand what's going on. And once we take a little bit closer look and see what this autoantibody actually means, that gives us a little bit better idea of what's going on in our body and gives us chances to address it and attempt to make it better. Okay. So GAD, Glutamic Acid Decarboxylase, or glutamate decarboxylase. This is an enzyme in the body related to GABA synthesis. Now, GABA is Gamma-Aminobutyric Acid. It is an important neurotransmitter in our nervous system. It's got a whole bunch of different things that it is good for in the body. We'll get to that a little bit later in the podcast. But brass tacks, what GAD does and what it is. GAD is an enzyme that turns glutamate, which is an amino acid used for making proteins that our body naturally makes. It's a non-essential amino acid, but GAD takes this amino acid and helps turn it into GABA. Okay, and then that neurotransmitter has all of its effects throughout the body. There are two main types of GAD in the body: GAD67 and GAD65. This has to do with their structure. 67, I think, has two extra pieces to it that GAD65 does not. But in terms of their role and the kind of GAD that a GAD autoantibody test is telling you about, that's going to be GAD65 for us. So we'll see here, GAD65. This is more kind of like the background, baseline type things going on in the body related to GABA, right? This is like if nothing was going on in our body in terms of, we ate something, we experienced something. This is like the baseline. This is taking care of just maintenance type stuff. GAD65 is more activity dependent, right? So when we experience trauma or stress of some kind, this is the enzyme that's being used to make GABA for those types of activities. This can be food intake. This can be, like I mentioned, the exercise. It can be trauma. Those kind of like reactive nervous system stimulating activities, that's GAD65. Now, GAD65 cells, or cells with GAD65 in it, are found in two main places. The first is in the brain, right? Neurons, interneurons, those super heavy in neurotransmitters, but they're also found in pancreatic beta cells, which is very unique and shows, I think, indicates a fairly strong connection between kind of that gut-brain axis, right? Because obviously beta cells are super important in digesting food. Beta cells are obviously very important in making nutrients available to be absorbed, which neurons and interneurons are obviously interested in. So beta cells are kind of like the key that allows the nutrients to get into the neurons, and this is kind of a good in support of that, essentially. So that's what GAD does. That's what it is. Now, what does that mean for those with altered glucose metabolism? Could be type 1 diabetes, could be type 2 diabetes, or just general insulin resistance. So, like I mentioned before, beta cells have GAD because beta cells make GABA. GAD exists within beta cells and reacts with glutamate to create GABA, which is what it does. Now, this occurs when our blood sugar increases, right? This is kind of at the beginnings of the inner workings of our cell, right? Our cells sense that our blood sugar is rising because we've just eaten food. This starts a whole cascade where GABA is created, and it is believed that this creation of GABA within the beta cell has a role in the beta cell being able to sense our blood sugar and create insulin to regulate it, okay? And it's not just related to beta cells. It also, there's a lot of research showing that it can also influence alpha cells, right? So GABA isn't necessarily just insulin production, it's glucose regulation in general, right? It can help influence the elevating of our blood sugar as well as the decreasing of our blood sugar. And so, as we know, diabetes has a lot to do with balancing our alpha uppers and our beta downers, right? To help kind of reach us or help us reach equilibrium. So GABA, again, its influence is undeniable. GAD's, is kind of this. This GAD allows for GABA to do what it needs to do. And so we need to make sure that GAD is taken care of for that exact reason, because without GAD, we're not able to make GABA. And when we can't make GABA, that greatly decreases our ability to regulate our blood sugar. Now, the question is, why do we have antibodies against such a critical enzyme for insulin release? Now, the common narrative, and this is one that I argue against fairly regularly, that our immune system has misidentified GAD and all of the receptors for GAD, and by doing this, it has offhandedly killed the beta cells. So the argument goes that something is wrong with our immune system, and it sees GAD, thinks it's a villain, and thinks that it's there to hurt us, and kills it. And by killing it, it inadvertently harms the beta cells and their ability to regulate our blood sugar, and they die off as a result. However, GAD exists elsewhere in the body. I mean, we talked about it in the brain. It exists in the gut as well. So for those with diabetes and with this immune system initiated stance, why is just GAD from beta cells being targeted by our immune system and not the GAD in our brain and in our gut? Because if that were true, if this were just an anti-GAD campaign by our immune system, people with diabetes would also have neurological disorders, because GAD in the brain is being affected, GAD in the gut is being affected, GAD in the beta cells are being affected. But those with diabetes are only experiencing this specific targeting of beta cells and nowhere else in the brain. Why? That kind of specificity for beta cells doesn't sit well with me when it comes to targeting the immune system as the initiator. Because if the immune system was the problem, it would attack all the GAD. It wouldn't. I don't know that it would differentiate where that GAD was coming from, and that would affect our brain. The next issue is that when GAD is an intracell enzyme. It belongs in the cell within the cell membrane. When it is contained within the cell, the immune system isn't needed to target it, right? So going back to that top point, the immune system is the villain mantra, says that our immune system targets our beta cells, targets the receptors, targets the enzyme itself, regardless of where it is, right? It's actually going into the cell and attacking. It is an active attack from our immune system. That's not really how it's believed to work, because if GAD is in the cell, that's indicating that the cell is healthy, right? It belongs in the cell. There is no stimulus for the immune system to form antibodies, right? The immune system is designed to clean up messes. And when GAD is inside the cell, that's an indication that there's no mess, right? There's no stimulus for the immune system to react. However, GAD autoantibodies only come about when these GAD enzymes are being spilled from beta cells. When GAD is spilled from beta cells, that's an indication of lysis and that the cell has been broken open. The cell breaks open. The immune system is like, oh, I got to clean this up. That's where those autoantibodies come from. But this requires that there is something happening to the beta cells before the immune system reacts and creates those autoantibodies to clean up GAD, right? So this is not, in my humble opinion, not initiated by the immune system. This is involving some other form of inflammation going on under the surface of the beta cell or adjacent to the immune system that is causing these beta cells harm so that they spill their contents and initiate an immune system before the immune system actually attacks the cell itself. So then that begs the question, what is it that's causing that initial spillover of the beta cell's contents? GAD is getting into our kind of, not the cytoplasm, but out into the open where the immune system can target it. So my question is, what is happening inside the beta cell that is causing it to self-destruct, essentially? Couple different options. I have talked ad nauseum about the role that iron overload plays in the destruction, the internal led destruction of beta cells. There are viral and bacterial infection theories talking about how our beta cells are being preferentially targeted by viruses and bacteria in order to steal resources from our body. There's also, this is a little bit further downstream of the previous two, but DNA damage, misfolded proteins, the idea that there is something inherently wrong with our beta cells that is causing them to just go awry and malfunction. And this malfunction is what's causing the spillover. In my humble opinion, right now, if I had to choose, I would say that there is interplay between the first, iron overload, and a viral and bacterial infection. I've talked before about how viruses and bacteria cause our body to overload on iron in a protective measure to prevent losing iron to viruses and bacteria, because that's an important part of what keeps viruses and bacteria alive. In an overloaded state of iron, because of our poor nutrition, we have a pre-existing abundance of iron. When we are subjected to viruses and bacteria, that compounds our initial overabundance and makes that iron-initiated inflammation even worse. That's what I'm believe is what's causing our beta cell distress and everything after. So, quick review. This is how you're sold this when you get your autoantibody panel back and you're GAD positive. So your immune system has misidentified GAD as a problem. It therefore targets your beta cells, and your beta cells are inadvertently killed off. Now, I don't buy this, because this description just completely neglects that. Why isn't our immune system targeting our brain or our gut specifically? Why is it just beta cells? Our immune system, if our immune system was truly defunct, it would be much more widespread, much more general. So what about our beta cells is causing this? That's something our current theory doesn't touch on. So what I'm proposing is that beta cells are under siege beforehand. Nutritional deficiencies, imbalances, talking about iron overload, viral takeover, bacterial infections. So these opportunistic invaders are sensing our imbalances and deficiencies, and they are invading and reaping the benefits of our dysfunctional and misfiring immunity. This is causing internal inflammation. This is causing our beta cells to malfunction, releasing GAD into circulation, where our immune system is like, oh no, the beta cells are spilling over. We've got to go clean up. And as a result of this cleanup effort, we're exhibiting GAD autoantibodies. So this starts a little bit of a tragic cycle once this has started, because once GAD is released from the beta cells, this activates the T cells of our immune system. These T cells coordinate with B cells, not to be confused with beta cells. B cells are different from beta cells. B cells are another form of white blood cell immune cells that are being used to produce antibodies for GAD and its receptors. So now we've kind of got like this immune system has initiated, it's got all the tools and resources to target GAD because they've spilled over from those beta cells. But now these autoantibodies, which were there to clean up the existing GAD, again, this is just theory, but those autoantibodies now may mistarget living beta cells. So in an effort to clean up, we're creating autoantibodies, and these autoantibodies may not have the selectivity or the ability to discern spillage from dead beta cells and living beta cells. So they may just be cleaning house when they were only supposed to be cleaning up what was spilled. And so here's just an easy graph starting up in the upper left. So beta cells are being harmed, right? And they are spilling their contents. You see that broken membrane there. This is, let's pretend this is GAD being spilled out. Our immune system senses it and creates all of these T cells and B cells to clean it up. Now, we're cleaning up the GAD, which has spilled, but we're also inadvertently targeting healthy cells. Those healthy cells are now being spilled, dumping more GAD. Dumping more GAD initiates more of an immune system reaction, and it just kind of is this vicious positive feedback loop. Okay? Bad news bears. So, why does this matter to beta cells and their ability to create insulin? Let's think about why GABA matters in the first place. And when you dive a little bit deeper into GABA and its role in insulin production and beta cell health, it's so incredibly important, and it opens up possibilities for GABA being a possible therapy when it comes to restoring beta cell function. So GABA affects multiple cell types directly and indirectly influencing glucose metabolism. We talked about alpha cells before. We talked about beta cells before. It has a role in nervous system regulation. By affecting the nervous system, it basically has its hands on a little bit of everything. So it's incredibly important. GABA signaling has been shown to promote beta cell proliferation and survival, so direct ties to not just stopping damage, but also initiating a rebuild effort to build more beta cells. So it can protect our existing beta cells against apoptosis, which is crucial for maintaining that alpha beta cell balance. It's even been shown to convert alpha cells, which are making glucagon and making our blood sugar go up, and changing them to beta cells, which create insulin and bring us down. So GABA has the potential to be this amazing tool to restore our alpha beta balance. So let's just take a quick look at the GABA being produced by pancreatic beta cells and what it does. So islet function, beta cell protection, and the modulation of secretion, right? Islet function. GABA is produced and secreted by beta cells. It acts in an autocrine, which means it acts directly. I believe I'm getting this right. Autocrine means it acts directly at the site of where it's having effect, but also in a paracrine manner, which means it's kind of like upstream or downstream of the desired effect. Its role is not just immediately where it happens. It affects many, many things away from where the reaction is actually happening. Beta cell protection. So GABAergic signaling has been shown to promote beta cell survival and proliferation. So we're not just preserving our beta cells that we have, we're promoting more. And then the modulation of secretion. So GABA can help regulate how insulin is secreted. So activating certain receptors of GABA on beta cells is suggesting that the availability of GABA is influencing how beta cells release insulin, which is incredibly important. The more GABA, it seems to be that the more GABA we have available and the more sensitive our receptors are to GABA, the better control of our blood sugar that we have. And this goes on and on and on. So these are the specifics of glucose metabolism. So secreting glucagon. So GABA can also influence the secretion of glucagon. It's not just beta cells and insulin, it's alpha cells and glucagon as well. So reduced GABA signaling has been associated with increased glucagon release. So it works both ways. More GABA, more insulin. Less GABA, more alpha cells and more glucagon, right? So when you look at what type 1 diabetes does, what type 2 diabetes does, it clearly lines up with an underabundance, an underserving of GABA, right? Because we're all glucagon heavy, we're all alpha cell heavy as opposed to beta cells. Islet homeostasis. So by balancing the secretion of insulin and glucagon, GABAergic mechanisms contribute to the overall homeostasis of glucose levels in the blood. We need GABA in order to regulate our blood sugars. Simple as that. And then peripheral effects. Some studies have indicated that GABA might act on peripheral tissues, such as muscle and liver, influencing glucose uptake and metabolism. So Obviously, muscle has a huge influence on insulin sensitivity. Obviously, the liver has a huge role in the health of the pancreas and the utility of the pancreas. It's no surprise that GABA would probably also have an influence on these kind of secondary characters in the diabetes story. So here are just some titles. If you were to type in GABA and type 1 diabetes or GABA and beta cells, you would get so many different papers with awesome output and information talking about the ways in which GABA influences diabetes. So at the top, GABA induces a hormonal counter-regulatory response in subjects with long-standing type 1 diabetes. This paper looked at GABA's ability to protect type 1 diabetics from hypoglycemia. So they put these humans who had diabetes for a long period of time and gave them, I believe, enough insulin to trend them into hypoglycemia. When they took GABA allowed for their body to naturally create glucagon to protect against lows. Okay, so this is kind of promoting the idea that GABA isn't just insulin secretion, it's glucose homeostasis. So it's able to touch on both ends, both the alpha glucagon release and the beta cell insulin release. And at the bottom, GABA receptor agonist-based immunotherapy for type 1 diabetes in NOD mice. NOD mice are basically mice that are genetically bred to become diabetic. But what they did is they gave them drugs that made them more GABA sensitive. And when they induced this GABA sensitivity and paired it with increasing their GABA intake, these mice experienced type 1 diabetes remission. Fascinating. So, okay, more sensitive to GABA, better glucose response. And then at the top there, GABA promotes human beta cell proliferation and modulates glucose homeostasis. That's pretty incredible. What they did in that top paper is that they took beta cells from humans, they grafted it into a mouse so that they could examine over a period of time with GABA exposure how these beta cells survived and how they proliferated. And it showed that GABA had a protective effect on existing beta cells and actually showed to promote more beta cells for the beta cells that were there. And then this is personally my favorite, down at the bottom. Long-term GABA administration induces alpha cell-mediated beta-like cell neogenesis. So 2 weeks of taking GABA supplements led alpha cells to exhibit beta cell-like activity. So this is showing our body's ability to take an alpha cell and basically flip a switch and turn it into a beta cell. Isn't that that's amazing? That's incredible. So it just goes to show that our body is extremely flexible and prone to balance given the correct resources, right? So GABA was able to take alpha cells and turn them into beta cells, which is just in 2 weeks' time. So now with all of this information, okay, GAD is important. Okay, GABA is important. What are we, the people with experiencing diabetes, what are we supposed to do about it? So quick review, GABA comes from where? Main spot is the brain. It also comes from the beta cells, and it also comes from the gut. So when it comes to approaches to actually impact our GABA levels, what do we need to regulate? Our brain, right? And the nervous system, right? This is the command center, where all the signals are originating. Our beta cells, obviously we need to take care of our diet and lifestyle. We need our body to have the resources it needs to build the structures that are housing GAD and producing GAD. And then our gut. Got to take care of our gut. That the gut-brain axis is undeniable at this point. And so we need to be making sure that we're giving our body good things in order for our body to give us good things back. So dietary approaches. GABA-rich foods tend to be, fermented foods are very high in GABA. This could be kimchi, sauerkraut, yogurt, kefir, tempeh. All of these fermented foods are very, they're sold commercially as being very gut healthy. It's no coincidence that their pro gut health stance also influences their GABA content. Okay. Green tea. Green tea is rich in an amino acid called L-theanine. L-theanine is very influential in the production of GABA. So more L-theanine you have, the better your body's ability to create GABA. And then we're talking about the gut-brain axis. So fiber and nutrient-rich foods. These are kind of just like generic, broccoli, leafy greens, potatoes. These are all fiber-rich. They are all kind of probiotic in terms of our gut health and our gut's ability to sustain healthy tissue and absorb nutrients and harbor good bacteria. These are all things that are going to put our body in a good position to make its own GABA. And then in terms of amino acids, right, proteins, glutamic acid, so glutamate, which is the amino acid that GAD reacts with to make GABA. So this is like a major, major resource for our body's ability to make GABA. There's foods, tomatoes, mushrooms, and soy. Soy kind of sends people up the wall a little bit, but in doses of, in the non-GMO variety, it can be a very good thing. So tomatoes, mushrooms, and soy are foods very rich in glutamate, which is a precursor to the production of GABA. You can actually supplement GABA. The bioavailability of GABA is relatively low. However, there are new forms of GABA that are being sold commercially that advertise being absorbed better. Pharma-GABA by Thorne Research. I have a link in the description where you can actually purchase Pharma-GABA at a discount. That will be in the description. But you can supplement GABA and put GABA into your system manually, as opposed to kind of just relying on the resources and our body's inner mechanisms to make it. Same goes for L-theanine. I mentioned L-theanine being in green tea and how L-theanine helps boost GABA production. You can supplement L-theanine directly. This is a way to positively influence GABA. Magnesium, wouldn't you know it? I talked so much about magnesium and its influence on diabetes. One of those ways that it influences is that it acts to boost GABA and its ability to be received by the body. So magnesium specifically targets receptors for GABA. The more magnesium you have, the more sensitive to GABA you are. The more sensitive to GABA you are, the better your body's ability to make and release its own insulin. So I've got those types of magnesium available there, or those are the ones that you want to target more than any of the others. I also have links for those in my bio as well. And then taurine. We've all kind of heard of taurine more so in the energy, kind of like energy drinks. Like people talk about taurine being an important amino acid for metabolism. But wouldn't you know it, it's a GABA agonist. So whatever GABA you have in your system, taurine is something that enhances GABA's ability to do what it needs to do. So taurine is an important addition. So here's ways to influence the brain, right? Lifestyle and behavior is a big part of how our body regulates its nervous system. You gotta exercise. Specifically, aerobic activity is a great way to boost GABA production and make us more sensitive to the GABA that we're producing. It could be walking, it could be yoga, tai chi, running, biking, you name it. Mindfulness and stress reduction. So meditation, mindfulness, breathing techniques, These are all things that help reduce stress hormones that deplete GABA and promote relaxation, right? So if you wanted to combine the two, exercise and mindfulness, that's where yoga and Tai Chi are excellent additions to give your body a chance to make its own GABA. And then obviously with the, it's neurotransmitter. And I think this is probably the way that most people know about GABA is its role in sleep. I know Dr. Huberman in his Huberman podcast talks about GABA and sleep. But the better your sleep hygiene, the more regular your periods of sleep and your circadian rhythm, the better your GABA concentrations. You got to take care of yourself. And then on top of the dietary and the supplemental ways of getting this, you can also use herbal remedies. Valerian root, passion flower, lemon balm. These are all known, sold commercially for their calming effects and their ability to calm the nervous system. Calming the nervous system means that you are becoming more GABA sensitive, right? And so these are just 3 examples of very accessible, very common, very affordable ways to put your body in a good position to make and use its own GABA. I, for one, have valerian root and passion flower in my kitchen cupboard right now. I use it as a tea at night. So, wrapping up here. Too long, didn't read. Let's just quickly summarize what's going on. You need to regulate your nervous system, okay? Diabetes, the more we learn about it, is a disease of overstimulation, of the sympathetic nervous system becoming overly fatigued and taxing our body to the point where it is unable to recover. We are underrested and undernourished. We need to decrease our nervous system sensitivity. We need to increase our nutrient availability, okay? Eating whole foods, those that are rich in glutamate, those that are rich in GABA, and those that are going to promote conditions that allow for GABA to be used and absorbed and created. And lastly, exercise. You got to move. You got to move. These are all just like very basic human needs. You have to move, you have to eat well, and you have to be mindful and present. These are all things that are going to promote beta cell sensitivity, but it's all going to promote GABA creation and utilization. So, in summary, there is a likely primary underlying source of inflammation in our beta cells that is preceding the immune reaction that is causing GAD autoantibodies. GAD autoantibodies don't just like pop up out of nowhere, right? Our immune system has not gone rogue and has not just attacked our beta cells for no reason. There is something happening at the beta cell that is causing our immune to create these autoantibodies. Beta cells have a unique relationship with GABA. There is abundant research showing how positively GABA influences many different facets of diabetes, from saving beta cells, from promoting beta cell growth, and from actually addressing the balance of alpha cells and beta cells. Now it's just a matter of how can we coordinate this for people to actually act on it and use it on themselves. And then 3, supplementing GABA and promoting natural production and sensitivity to our natural GABA is very possible and accessible. I mean, we talked about whole foods, we talked about natural remedies and supplements. This is not like something clinical by any means, right? It's a feasible way of managing diabetes development and progression, and is something that we need to pay attention to. And lastly, thank you for being here. Thank you for joining the Diabetics for Diabetics family. I've got a link for the Beta Cell Project, which is a Discord for this community of those who are tired of type 1 and want to get rid of it. There are plenty of ways that you can support this channel. Subscribe, follow, share with your friends, with your colleagues, with parents of kids with diabetes. If you have diabetes, if you know someone who has diabetes, let's get my content in their hands so that we can instill hope. We can start to sharpen people's eyes and attention for possibilities, because let me tell you, they are there. It's just a matter of what we are going to do in order to kind of put the puzzle pieces together and actually start to heal one another. Okay. Supplement links in the bio. So if you are interested in supplementing and trying some of these things out, I have links for you for brands that I use, that I trust. It is all there. If you have any questions on anything, do not hesitate to reach out in the comments. Like I said, I'm on TikTok, I'm on Discord. I am active in all of those communities. Do not hesitate to ask. And then I've got educational resources as well. I've got a supplement and herbal remedy guide. I've got a nutrition guide for things that I look for in the grocery store. I've got my book, An Ironclad Cause, which outlines the underlying mechanisms that we mentioned before, talking about how iron overload influences beta cell health. All things that you can do to help me continue this effort, right? So with that, this is episode 40 of Diabetics for Diabetics Radio. I thank you so much for being here. Enjoy the rest of your day, and cheers.